Hey, um, hi everyone. So I've, I've, this is a topic that I've been super passionate about for a while. I would say many years. And I started as an engineer somewhere in the late 90s, and then have been in the individual contributor role for quite a while, for I don't know, maybe 13, 14 years. And then I started leading teams, and all of that time, basically, I kept thinking, um, where am I wasting my time as an engineer? And then I started asking the question at scale, where are my engineers wasting their time, right? Um, and so today we should talk about two things that make an engineer's life easier: continuous delivery and self-healing systems. But those things are not just making software developers happy. They're also making the businesses that pay those software developers um, more successful. Yeah. Um, so that being said, we shall cover a couple of things. First, I want to enjoy my life, and I spend a lot of time at work, right? So how do I do that? How do I do that for other people as well? Once you start leading people, you start thinking, well, my life is great now. How do I make those people's lives great? Because they are the ones that are pissing me off when they are not happy, right? Um, the other thing is that time is precious. So the demand for developers is becoming bigger and bigger and bigger, and it's not going to stop, right? And so we are paying tons of money for smart people. So how do I use those smart people to do what their brains can produce, not their hands? Has been a question for me for a while. And continuous delivery and self-healing systems have increased efficiency for me quite a while over the last couple of years. So who am I? Alex Popov. I lead the engineering team of Uber in Sofia. Before that, I was with a couple of other unicorns. Usually when I join a unicorn, it stops being a unicorn, but still I have a decent history with those. But in those companies, basically, I've learned that success is relates to explosive growth, and your engineering systems need to be able to cope with that. Many businesses are basically failing when the software they built is not coping with their success. Um, on the left is Alex that is dealing with repetitive stuff and is not happy during the day. On the right is my usual day-to-day Alex. So why are we talking about this? As I said, like, we all want to build amazing products, right? At the end of the day, this is the goal for each of us. And in order to have that, you need to have an amazing user experience. An amazing user experience comes usually with your competitive advantages. What kinds of features is that software providing to your users? What kind of problems is it solving for them? And you're not going to be the only one out there solving those problems. So you want to have more than your competitors. You want to put the cool stuff that you're producing before them, not after, right? You want them to catch up with you, not you catching up with their features. But once you have that, you grow fast and you're successful. And when you're successful, you enjoy what you're doing, right? And so I believe there are two components to delivering that value to an end user. And the first component is the proactive component, where we say, hey, how do we deliver what we just did as fast as possible, but also in a way that is not going to ruin the user experience, without dealing with the boring stuff around all this. But the second piece here is once we deliver that to that user, how do we make so that we don't have to stay 24/7 and maintain it so that it doesn't break, right? Um, a little bit of context. The one thing that I've always hated as a developer was to sit down and debug something that especially other people have produced. And so if you dump into your production systems, I don't know, 50,000 lines of code that were produced by, I don't know, 100 developers, it's very hard to make sure that you have control over this, and you're not spending enormous amounts of time to deal with the problems that this is bringing to production. Um, and at the end of the day, I became a developer because I was lazy, right? The machine can do a lot of stuff for me. I just need to learn to code, right? And to learn to code requires a bit of curiosity. And so if you employ that at the start of your career, you become a developer, and then you start dealing with problems that you don't like. But if you repeat that, you basically start learning more stuff and start making your life easier, and start learning more stuff and start making your life easier. And it's a cycle. But that cycle basically allows me and my engineers to enjoy what we do on a daily basis. About actually more than 40% of our day-to-day time is spent working. I'm going to talk specifically in the context of distributed systems, but those things are applicable to many places. Still, they are not a silver bullet, and I will cover that a bit later. But the requirements for distributed systems are that they need to scale. I was talking about success, and success leads to increase in your data, increase in your users, increase in stuff. And that increase is usually exponential. You cannot reactively deal with it. You need to design your systems in a way that they scale. It needs to be responsive. So even if your systems scale amazingly well, your users are growing, and if they are not liking what they see or experience, that growth is going to disappear very fast. So they need to be super responsive. And the other thing is reliability. Those systems, even if they have amazing features and they are super responsive, the moment they stop, your user is pissed and is going somewhere else. Over the years, the way we deliver software to those users have changed a lot. Back when I was starting, we had these release cycles that are like 6 months, a year, and it was a whole ritual to release something in production. For months, I would say, people would prepare for that, and then it will go into production, and then everyone goes crazy about how to keep it alive there. Then over the years, basically, certain engineering practices started appearing that led to much smaller cycles. So I remember the times when we were releasing less than a month as a frequency, and we were super proud of it. And today, looking back, I feel pity about myself and my pride of that. And later, even people started talking about continuous delivery. And even today, continuous delivery evolves. I'm still talking to people who are saying, oh, we're doing continuous delivery. How often do you release to production? Every 2 weeks. No, that's not continuous delivery. Like, continuous delivery is one developer can throw stuff into production 4 or 5 times a day and not think about it. I don't know where this is going. Maybe in the future, things will appear in production before we even code them. We'll see about that. The goal of having that, though, is very simple. And it's good for the business, and it's good for the engineering. Rapid prototyping is something that has proven that, especially with the explosion of the internet economy, is a key factor of the success of an organization. Ownership of what you build is also something very important. Removing all the obstacles on the path from writing a piece of code to having it in production, serving the needs of your users, is extremely important. This should be a very short time frame. Minimum waste, as I already said, I need my engineers to think and to come up with new ideas and to come up with good solutions of hard problems, not to deal with debugging, not to deal with watching dashboards, not to deal with problems that are hard to find. Machines are really good at that, and we should exploit that. That in most modern engineering organizations, that led to the fact that a lot of roles, classic software engineering roles, have disappeared. Like, almost no one is employing QAs in those fast-growing companies. There are no release engineers. I remember the days when we had release engineers and DBAs and infrastructure folks. Today, the software engineer, owns all of it. It basically has the tools that make their life easy. They don't need to know much in order to cover for all of that, and that allows them to deploy a gazillion times a day in production. They own their systems there. They own their infrastructure, they own their security, they own their testing, etc. What is the usual developer cycle? The part that we still cannot automate is coding. This is where we need the people, and this is where I want my people to focus. Building is something that has been automated for quite a while. If you're still building manually, I pity you. Go out there and spend the time to automate that. Testing is something that is, as I said, evolving very rapidly. Automation of testing is not the result of the fact that we believe QAs are not doing a good job. It is a result of the fact that QAs don't scale. In such a fast-growing environment, in order for you to have QAs that are guaranteeing the quality of the product, you need to have probably 10 times more QAs than developers. We just cannot find that many people to take care of that problem. This is why it is important to automate this piece. Deployment is also something that is automated for a while, and monitoring is the key piece here. We employ people to take care of the quality of systems, whether this is at the release cycle or post the release cycle, because they can make decisions, and people make decisions based on data. The machine cannot replace a person if it doesn't have that data. So the monitoring here, the metrics and monitoring here is very important. And reaction. When I was doing analysis of where my engineers spending their time when they wake up at like 2 a.m. in the morning to fix something, 9 out of 10 times they were doing stuff that is boring, stupid, that does not require their engineering competencies and can be automated. The baseline for having continuous delivery, as I said, metrics, metrics, metrics. Data is everything. The better your data, the better your ability to react in an automated fashion. Monitoring obviously needs to be attached to that data, because on its own, it's just wasting money. It's just taking storage space. Alerting is the other piece that a lot of people are basically doing right now. Monitoring basically triggers signals. Those signals end up as alerts with engineers. Is that really necessary is a question that I've asked multiple times in multiple teams. You have the hooks. Those hooks can be attached to machine often. Now, in the world of distributed systems, containers are something that has made a lot of those things possible. It gives us the elasticity, and it gives us the fast response time when something breaks. Smart load balancers are also a key piece here. Without them, it's very hard to react to problems with the machine. People need to get involved. Auto-scaling is also something that helps a lot. It's not a silver bullet, but it allows you to basically buy yourself a buffer of time to react to a problem. And experimentation frameworks are more on the proactive side, where we test something before we actually deploy it. The technologies that we need to have that in place, test frameworks is something that all of us have today. Logging as well, monitoring and alerting. Most modern engineering organizations have that for many, many years. Container infrastructure is something that, as I said, allowed much faster reaction times when we do those things. Deployment and rollout is also something that is done very differently in very different organizations. I've seen extremes that I love, where you basically just put a code that just ran through the tests directly into production, and you don't care about it. And places where this goes through a bunch of intermediary environments where people test again and again and again. But that is slowing us down. And so ideally, those should be removed from your systems if possible. A/B testing is something that is picking up a lot the last 10 years maybe. It allows you basically to see at a very small scale what are the effects of the changes that you're making. Load testing is, again, you never know when the universe will surprise you. There are those cycles in our businesses that we can predict, like New Year is coming and people will suddenly start buying presents for everyone. But there are those that we cannot predict. A bomb just exploded on an airport and people are fleeing from there. Test tenancies, as I said, I've seen all kinds of setups here. This is still evolving rapidly. I believe that it's very context specific. So in some places you cannot just have deployments directly to production. In some places you need to have those intermediary environments. In others, people just do more than they need to do. The self-healing is the reactive part. No matter how good we are at making sure that we deploy safely, things will break. The universe is always bad with us. Like it's always the enemy. Infrastructure breaks all the time, especially now that people move to the cloud. That is becoming something that you don't have direct control over. Power disappears. Networks act funny. People are unpredictable as well. The less people are involved in any of the processes that require deploying a product to the end user, the better. But basically we need to deal with this, and this is where self-healing comes in. A lot of people are saying, no, this is too complex, we are not going to invest in it. Truth is that it is not. Often an engineer in my team wakes up in the middle of the night and then I ask them, hey, what happened? They said, well, it was a memory leak. Well, if we're using containers, why should a person wake up in the middle of the night to queue a few containers and put them back up until the morning comes and we can handle the issue properly? A service has not been done right and is just killing another service or a bunch of other services. Well, why not rate limit those and not wake up at night? And there are complex things like anomaly detection and other stuff that, again, looks complex, but there's so much technology freely available today as open source projects, as stuff that costs no money, that it's really not that complex to put some serious technology that would make decisions instead of a human. So the other piece here is that the stuff that I've shown you that we use as baseline to have continuous delivery can be reused for self-healing. So once you've built continuous delivery, it is a waste of resources to not reuse those systems in order to have a proper self-healing. Health checks are something that is typical for most systems today. They basically monitor the health of those systems and report them. Operational and business metrics. So a lot of people are saying, well, I'm watching my availability or my latency or my 500 errors. That's not enough. Often you deploy something in production and it looks great on the operational side of things, but then it just dropped your revenue with 1%, or it just basically ruined the experience for a user who is switching to someone else. You're losing people. We need to monitor those as well. I've often seen crazy cases where everything seems to work. Nobody can explain why a business metrics has been impacted, but it is impacted and we need to react to that. The other piece that I've aggressively tried to change over time is that people look at dashboards. Like we have our Grafanas and we keep looking at our Grafana. People are not good at looking at time series data. Machines are much better. They can react much faster. They can see patterns there that we cannot see, etc. And so putting the machine to do that work is, I believe, extremely important. The other piece is that technology, so there's open source technology that allows us to debug our systems in an automated fashion end to end. Back in the day when I started building complex systems, we had to synchronize between multiple teams to know each other's code, to look into other people's good and bad stuff in production. Today, machines are actually doing that quite nicely. And often if we employ that into a real-time monitoring system, even if it cannot handle automatically the problem, it still will wake up a developer, but that developer now has a lot of information that tells that developer where is the problem actually, instead of that person spending hours and hours to just find the problem in order to react. And the other piece is rational SLAs. So I've seen crazy stuff here. Some people say, hey, this is a service that can stop the whole business, so it needs to have a reaction time of like 15 minutes. Well, what is the actual user experience there? Like that user may expect the results that are coming out of that service in 8 hours. Why should we wake up someone in the middle of the night? So have rational SLAs. Don't put those as under generic rules that are saying these are the contracts that guarantee the quality of my systems. Over the years, I've been scared to employ the machine to do a lot of this. The first time I had to make a decision whether I shall have QAs or not, it was a very hard decision. I didn't believe that this will work. My developers didn't believe that this will work. My QAs were definitely sure that this is not going to work. But it worked. It worked because the QAs don't guarantee that what you put in production is good. And the load on those people was increasing so fast over the years that they were overwhelmed, unhappy, and were letting things slip through in production systems. Monitoring is something that solved a lot of those problems. I know companies that are not even doing tests, and their code base is a freaking mess. And I never understood how they have such good availability in production because I'm using their products. And then I met some of their engineers and they said, well, we have amazingly good monitoring systems that are reacting automatically to everything that happens, and this is why you are not seeing it. But they break all the time. And they didn't care. Now, I've never went so far into the extreme to say we are not going to be writing tests. But it works for some people. And I'm talking, without naming anyone, companies that have hundreds of millions of users. Containers are something that helps a lot. If you haven't containerized your product yet, do it. It takes literally seconds to drop something and put a different version of it up. So your availability increases dramatically when you have that elasticity. The other piece is the Geo Distribution. If your product is such that can do that, by all means, don't put all your eggs into a single basket. At Uber, I've seen how a data center that costs like, I don't know, there were something like 60,000 physical hosts that Uber owns just went down because someone plugged a 20,000 volt cable in the wrong place. Yeah, and the other piece here is that propagation of those errors. Even if the machine cannot handle the problem, it will still wake up a developer. So we are losing nothing. Like the reaction time, it's not going to get worse if you employ the machine. But even when we wake a developer, there are extreme inefficiencies. I've seen people, or we recently had a case where about 100 developers were woken up by PagerDuty at the same time because something broke up very early in the dependency cycle, chain, and then basically propagated throughout the whole system. And so probably 90 of those 100 developers were waking up, looking at their phone, opening their laptop, looking at what's happening and saying, oh, this is not us, closing it and going back to that. This is not cool experience, okay? So, but there are systems that are already solving that problem. We have something called Cascading Alerts that basically are saying, hey, the problem is here. We are not going to wake up anyone, even though those systems are still breaking, like the depending systems. But we know where the problem is. And the machine is really good at finding that out. You don't need to wake up 100 people to find that there are 2 that are needed out of those 100. So yeah, the outcome of having those 2 things is very simple. We are serving more than 100 million users every month. Traffic, load, infrastructure, they are all at crazy scales. But the ultimate goal is that nobody wakes up at night. This is still not happening. I'm pretty sure that machines will get smart enough to solve all of the problems that we are solving when we wake up at night. But we are getting there. Comparing to what the world looked like 20 years ago when I was starting to code, we are very close to a place where developers can just sit down and do what they're good at and what they enjoy versus dealing with the stuff that a machine can do for us. Thank you.